Good afternoon, friends. We have a practical session yesterday on artificial neural networks. I have shown you um, an example of a data science based an example that we considered a diabetic patient's data. On top of it, we used Jupyter Notebook and we we learned the data using ANN, and further we use it to classify and predict whether for a given conditions, under a given conditions, whether the patient is having diabetes or not. That we have done yesterday. I did not share that program. I will share now. Today I will share practice that program. Today, I will go to explain again a theoretical aspects which we discussed earlier. Our motto is to understand what is an optimization problem. Since we are discussing about the genetic algorithms, so optimization problem is important for us. I'll recall what is optimization problem, what are the applications of optimization problem, and then today's topic is genetic programming. What is genetic algorithm is different and genetic programming is different, right? What is genetic programming? I will show you a quick things and simple example also. As we discussed previously, what is an optimization problem? Genetic algorithm is used to solve the optimization problem. Whereas remaining all the problems are classification, clustering, regression, and all. Come to the genetic algorithm, it is purely meant for optimization problem. So that's why we need to know what is an optimization problem. We have this example I have shown you 2 days back. You have a bag and different items. Each item is represented with X. How you can make different things into a bag to maximize the profit, in order to maximize the profit. That we discussed like an abstract problem in algorithm problem, design and analysis of algorithms. How we can maximize the complete use the bag and maximize the capacity of the bag and get the maximum profit. Maximum profit in the sense to have the maximum number of maximum number of objects into a bag. This is the useful. You need to frame a mathematical optimization. These are all we discussed, but I'm recalling the things since we have got some gap. That's why I'm recalling this. This may be expected like a one mark question. What is the local optimum? What is a global optimum? I think I given an excellent example for that. How to remember what is a local optimum and global optimum. This application um, image image deblurring. Blurred image can be deblurred. This is a minimization problem rather than a maximization problem. We need to minimize the error. Sorry, minimize the blurring. This is almost all the machine learning problems can be rewritten as a optimization problem. That means to minimize the error between expected minus actual. What is the expected result? What is the actual result? The difference between them should be minimized. It's a transportation problem for a traveling salesman problem. We can understood like optimization, where it can be useful for the companies like Uber and Ola. Those companies can use this type of algorithms. Every time, every time you mention the relevant real-time application for a concept given to you, genetic support, genetic algorithm, explain genetic algorithms in your exams. The question is like this: explain genetic algorithm. Then you mention that it is an optimization problem. It should be solved like this, like this. And you give some example for optimization problem where it can be practically useful. As I told you, like the companies use with Uber and Ola companies, GIS based companies can be used. Like that, you need to mention in your exams, like example, and also in the case of interview, the same thing. What are the concepts you learned in machine learning? Suppose the concept, suppose the question asked you like this: what are the concepts you learned you as a part of machine learning? How far they will be useful in a practical scenario? This type of scenarios you can explain and convince them. Is a vehicle routing problem. I explained. As I told you, bidding the data also we can use Amazon. Companies like Amazon and Google Shopping can use the genetic algorithms. Yes. Medical domain also use the data driven problems for genetic algorithms. That is indirectly optimization problems. These are the various applications of genetic algorithms. These are all the things I shown you already. Now the genetic programming. It's a small concept, genetic programming. This is a parse tree. Suppose x plus x square minus x. See here, this minus here you have minus. This minus is represented here. This minus. That means after that you have called x. You have a term called x here. That is this x. Left to that you have a plus. You have plus. This plus is represented here. From for that left part there is a x that is represented here. After plus, after right side there is x square that is represented here. Likewise, every expression can be represented like a parse tree. If you consider like this sin x plus square root of this is sin x plus square root of x square plus y can be represented like a parse tree like this. And here you apply the very important thing is this crossover operation can be applicable over here. How I can show? So for the first this focus on this particular part. How we can generate this? Forget about this one temporarily. Forget about this one. Come to crossover point, crossover operation. Here the this is the crossover point here. Here is the another crossover. As I told you earlier, crossover means there is up to one crossover point. Copy the elements from the first parent, and after that copy the elements from the second parent. I told you. So that's why here you can see these mm, this bolded part. This one is a crossover point here. This bolded point part is a crossover point. So that's why. mm, we need to copy the things, entire things from one parent to the here, and after crossover point, the next part to the another. Place. So that's why here first part is chosen and copied here, and the second part is here. If you change that second, if you change that crossover points, if you first consider the first parent and the second after that the second parent, you will get this parts tree, another parts tree. This is the crossover operation useful. Yeah, this is very yes, 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 yes. Sir, why you are explaining cross parse tree and all? How far those are useful in a compiler design? The parse tree is the very important aspect. So in that regard, um, we I think you know you have heard about the Lisp programming, LISP. That is the first programming language used the tree-based genetic programming. Genetic programming applicable in a compiler design, in a design of the compiler, and solving a parse trees. That is very that solving a parse trees, genetic programming can be useful. So in the recent languages like Python, Java, and C++ also used in genetic programming. Not only that, yesterday you have used Jupyter Notebook. That is nothing but Python. That Python supports GPUs rather than it supports CPU, and more than it supports GPU also. For that GPU support, we need Caro GP, Caro genetic programming, tree-based programming. That is all built in genetic algorithms. So genetic algorithms not only for optimization, they are for to process a parse trees. Parse trees, that means indirectly they are useful in compiler, writing a compiler program. So this slide is very useful. What are the applications of genetic programming rather than genetic algorithm? Genetic programming applications, you can write all these things. For solving a parse trees using crossover operation. I have shown you this here, crossover operation. First two are the parent nodes, parent trees. Second two are the offsprings, like zeros and ones. Yesterday we have seen in the previous class we have seen about that, right? Search techniques. These are all the entire search techniques. Where the main our focus is on genetic algorithms and genetic programming, which are come from evolutionary algorithms. Evolutionary algorithms means nothing but inspired by a um, inspired by a nature. Inspired by nature here is genetics and uh, whereas applications like mutation crossover, etc. These are the different search techniques. This is one simple problem used by programming, genetic programming. This will be useful in understanding how the compiler programming is written. Is a application that consists of some stack-based application. We need to spell universal. How this spelling can be obtained is there are different terminals like terminology like CS, TB, and NN, and move to the stack, move to table. Empty means move to table. EQ means equal. NOT means not. DU means do until. That is nothing but a while loop. So this, if you apply this terminology, then we can spell out the universal spelling. It's a simple example one can try. It's not much great. You are here. You can have this terminology and you can be able to spell universal spelling. These are useful in understanding that genetic programming has a good relation with explaining in solving the parse trees. Parse trees everywhere useful in a compiler. Compiler is used by almost all the languages, and modern languages also use the compiler. So that is all about genetic programming, right? So as for the unit 4 is concerned, he explained about artificial neural networks, how artificial neural networks works, all those things we explained, and we have taken some example also and implemented yesterday artificial neural networks. That is all finished about the artificial neural network. Now genetic algorithms, come to genetic algorithms, we have learned all the terminology involved in that genetic algorithms, and we have focused on how genetic algorithms useful, what is an optimization problem, how real-time scenario like image processing, machine learning, GIS based, and data-driven problems like with database applications, etc., etc. And at the last, we studied about genetic programming. Genetic programming, in the sense, useful for solving a parse tree. That is nothing but a compiler program, compiler design will be useful. How crossover application can be useful in genetic programming. This is the best example, crossover application. Right? Genetic programming, exact applications of genetic programming where can be useful. These are the different search techniques. This is a simple problem. Just to use this problem will be useful to understand the manipulations we can do using inside of the memory that can be solved by a genetic program. So any doubts? Yeah, I think almost all we completed our syllabus aspects to genetic algorithms and artificial neural networks with search-based techniques. And any doubts you have, you can chat here, or you can ask directly.